Hello, this is a video made for the 4th year honors final project Animating Models of Computation by Arnas Gabrielius Slepikas. The application produced for this project is a finite state automata animator. It allows the users to create multiple automata at the same time, one automaton per tab. For convenience, these tabs can be renamed. Creating new models is done through interaction with mouse. Left-clicking the editing panel adds new states. Transitions between them can be added by pressing and holding the left mouse button on a state and dragging it to another. This brings up a menu to add labels. Users can enter multiple transition labels after pressing More button. But in order for the transition to appear in the model, at least one label must be entered. Acceptable characters are alphanumeric. Users may also enter duplicates, however, only unique characters will be shown in the model. If there already exists a transition, an error message is shown. What the users can do instead is right-click on the edge and select the Edit Label option. This brings up the same menu as the one for creating a new one. States and transitions can be removed by right-clicking on them and selecting the Delete option. This was all done using Editing mouse mode, selectable from the Mode menu. In addition to this, there's also Picking mouse mode, which allows users to drag states holding left mouse button. Shape of transitions, however, cannot be changed. This mode also allows usage of right mouse button to create and edit directed edges between states. This once again brings up the already shown menu. Both modes also have the option to set one state to be a starting one and one or more states to become accepting. An alternative way to build an automaton is to build one from a regular expression. There is an option to do that in the regex menu. File menu allows models to be saved and loaded. Users may also choose to save the entire workspace as well. Loaded automata use automatic layout algorithms since the layout data is not saved. Using mouse, however, one can move the states around and change the loaded models. Then there is the refactor menu. It has 3 layout algorithms ready for use. Using them overrides the current layout. Refactor menu has an option to minimize a DFA. Using that on an NFA, however, will show an error. There is also an option to remove unreachable states. That is, states that cannot be reached by any sequence of transitions from the starting state. There is the option to duplicate an automaton. A copy is placed in a different tab. However, the layout is not preserved. There is also the option to convert a non-deterministic FSA to a deterministic one. Using this algorithm and following it up with the minimization produces a minimal DFA corresponding to the starting automaton. These are all the features meant for creating and editing a finite state automaton. There is also the animation part for simulating automata. When switching to the animation panel, user is prompted to select at least one model. Unselect models that do not have a starting state set are unselectable. Pressing Done without selecting anything moves user back to the editing panel. Let's select a model and move to the animation screen. In this mode, there are 3 buttons. Tape button allows entering the string to be simulated. Go button immediately tells whether the string is accepted. If no string is entered, it tests the empty string. Once a string is entered, it is shown in the bottom right. The user can then use Start button to go step by step. A marker shows which character of the string was the last one simulated. If the string is accepted, then a single path is precalculated for the purpose of animation. Otherwise, if the string is not recognized, the path will be built on the fly. For non-deterministic finite state automata, it means that a path will always be found if it exists. This concludes the demonstration of functionality present in the application.